Ba-bum. There it goes. Hey, all right. It says that the Hangout on Air is live. Hey, welcome everybody to Astronomy Daily Live. Hope everybody's doing well out there in the universe and the world. Yeah, it is 2 hours UTC, and once again, we're gathering together here, a group of friends, ever-growing group of friends, to just, forget about almost everything else and focus on astronomy and science and space and all other things nerdy. So yeah, I can see Uncle Bill is sort of peering in through the chat there a little bit, a couple of little eyes. So nice to see him in the chat. Hope everybody's doing well. It's been rainy here, so it's pretty normal in the wintertime to have a little bit of rain now and then. So it's rain in the desert is always very welcome. So come on down for sure. So cheers to that. I've got the HOH tonight, so cheers to that. Excellent. Always excellent. Always very nice. And let's see. On the panel, once again, Bobby. Hey, what's happening over there?
Nothing much. It's like the same old crap.
Good. We like it that way. Same old, just kind of same old thing. So good. No kinds of excitements or anything, and that's exactly how it should be, And when there is excitement, we just sort of want a little bit of excitement, right? So not too much. So good. And Tom is back on the panel.
I hope it doesn't get too much.
Yeah. We never want it to be too exciting. So anyway, hey there, Tom. What's going on?
Hey, Cosmic. Not too much going on. Today is a bit of one of those days in history that you might remember. Clyde Tombaugh was born on this day in 1906. He's the one who discovered Pluto. And I guess he also discovered quite a few asteroids while he was looking for Pluto. So he's got those on his resume. And I did not know this until tonight when I looked this up. He was born in Streator, Illinois, which is just about an hour from where I am. So.
Oh, wow, cool. Yeah, I know he grew up over in Kansas, in Lawrence, Kansas.
Yeah, he went to school, got his master's and his bachelor's, I think, in Kansas. And he actually did his studies there after he discovered Pluto. So he was quite an inquisitive youngster, I guess. He built some of his own telescopes and was searching the skies.
Yeah. Hey, I'll right back. I'll show you a book I've got. Hold on.
All right. So Tom, tell me about that dude that discovered Pluto.
Oh, yeah, there it is.
Clyde Tombaugh. He was kind of a self-made astronomer. He was searching the skies and found many asteroids while looking for Pluto. Born in 1906, I think 1997, something like that, when he passed.
Yeah. So if he was born in 1906 and he discovered Pluto in 1930, he was like 23 years old, right? 23, probably 23, because I forget exactly when, what month in 1930 Pluto was discovered. But yeah, so he was just a little kid.
Just a kid, yeah.
Yeah. So this is a really great book. that talks about the discovery of Pluto and how actually Clyde Tombaugh got the job, right? He built his own telescope.
Like like you used to like when you turn off your camera, you forgot to turn off the mic, and we can definitely hear the clamoring.
Oh, that's good. That's good. There's always clamoring. Always clamoring, for sure. I thought that there were pictures in here of his telescope. He built his own telescope when he was younger, and made I forget exactly how the story went, but he made a bunch of drawings and sent them to like the only observatory he knew of at the time. I thought there was a picture of him with his telescope in here. Yeah, there it is. So there he is with his homemade scope, and he made various observations, made some drawings, sent them to Lowell Observatory over in Flagstaff, and they said, "Hey, that guy's pretty good at that. So let's hire him to do this impossible task." I'm gonna focus my camera. It likes to go out of focus. There we go. But yeah, so this is a really, really great book. Tells the whole story. It's actually written by Clyde Tombaugh and Patrick Moore. So, and I think I've shown you this all before. I've got a bunch of things here. I went to a lecture that he gave once. So that was March 28th. I think that was 1988 is when I saw him. Just a little tiny little guy. Yeah, I mean, obviously, sort of hunched over a little bit, but sort of a small guy. And then I won't tell the full story about this, but I've actually got his signature in this book twice. All right, so here's the first one, and of course Patrick Moore's too. And then when I met him at this, I got him to sign it again. So that was cool. The only thing that I have to say about this lecture, right, is that it was very, very apparent that he had told this story a trillion times, right? And so he just basically, retold it again. No real emotion or anything at all. He just sort of, blasted it out there. So but I mean, I can understand that, right? But yeah, it was kind of cool to meet him. And this is a really, really good book, right? Because this is a firsthand account. And yeah, what a tedious task he had. We have software now that can do basically the same exact thing, the same comparison type of stuff is still going on now. You take a picture of a piece of the sky, and then you wait a certain amount of time, and then you take a picture of the same piece of sky, and then you look at the differences between those 2 or 3 or 4. And if anything is moving, well, you've got yourself a target, right? So yeah, but he had to do that, by eye, right? And that's just crazy, crazy, crazy. I think it took him from the time he started to the discovery. It wasn't very long. It was I'm not exactly sure. I think it was over a year, but I don't think it was 2 years. So, but yeah, can't imagine, basically sitting in front of like like a microscope, right? Looking at these 2 photographic plates that he had taken, a couple of months apart. In fact, I think in this book, he actually made some notes. And I think I've shown you these before too. So maybe I won't belabor it too long here if I can't find it. But I think the last time I showed you this, I went right to it. So yeah, here we go. So yeah, he actually made some little arrow marks there, right? And then over here he wrote a little thing in the margin. Can you read that? Is that the right way around? And put his initial there. So thought that was pretty cool.
Magnitude guide, Mon Delta
Gemorium, right?
Gemor. Okay.
Yeah. So Delta Gemini. Yeah. Yeah. These are the discovery plates, I think, if I remember right. And yeah, there he actually put an arrow next to it right there, right? And then on the discovery one, they actually marked it with a little thing, and you can see that thing has definitely moved a little bit, and it moved just by the right amount to indicate, that it was far enough away, to actually be that. So yeah, I don't know if this book is still in print. If it isn't, you might be able to find it at like a used bookstore or something. But yeah, great book for sure. Extremely inspiring for sure. So yeah, so that was 1906. So that he would have been 103 today, huh?
113.
113. Duh. Yeah.
And another fun fact, maybe not fun, but a piece of Clyde is still flying around in the cosmos. After his death, he was cremated, and they put a small portion of his ashes on the New Horizons spacecraft as it went to first explore Pluto and then on to the Kuiper Belt object.
Very cool. That's right.
So he's going to be traveling for a long time. Yeah.
Yeah. So he actually made it to that object he discovered, right? So yeah, and the interesting thing, right, is that that wasn't. I don't think that Pluto was necessarily the planet X that they were looking for, right? It doesn't have enough mass. Is that right? I forget exactly how that story goes.
We still kind of have that story going on today. They're still kind of looking for planet X or planet 9 and a certain mass, and I haven't quite found it yet. But
yeah. Well, that's that. Like I say, that one of the problems with modeling things is that there are so many parameters that it's kind of hard to nail down and be really sure about things. So undoubtedly there are some pretty interesting objects way out there, but yeah, whether they have any kind of influence on the motions of the planets here, it's hard to tell for sure. Well, cool. And so Tom, since I've got you here, what about like any kind of rocket launches or anything? Is there anything exciting? There really haven't been too many in the past few weeks or so.
Yeah, no, you're right. It has been pretty quiet. About the only thing I've seen that's scheduled is a Ariane 5 rocket tomorrow, February 5th at 2101 UTC, and that's going to be carrying a couple of satellites, one for Saudi Arabia and one for someone else. I can't see who it is. No, not sure. India. And a satellite for them too. But that's about it. Everything else is still marked as to be determined of the things they had talked about before. And like the Falcon 9, they still haven't got a date for that.
Okay. Yeah. Where is that rocket launching from? Is it from Guyana, or is it I guess that's probably where I think that's their primary launch.
Because it's the Ariane launch area number 3 in Kourou. I don't even know where that is.
Yeah, I don't either.
There's a
All right, well, cool. Yeah. So it's been a little bit slow for Rocketry. Well, and this is with full respect and all of that, but really, I think space people should really, and I don't know what it is, right? I don't know what it is. Maybe it's just a superstitious thing, right? But for some reason, the time, starting about the last week of January to the first couple of weeks of February, have been a lot of major disasters, right? With space flight, right? So maybe they're just sort of saying, well, whatever this vibe is, we're just going to avoid it, right? And not launch anything at all, because yeah, it seems as though, and I mean, you've got to assume that it's sort of a coincidence, right? But a lot of at least in terms of like American space flight, right? A lot of pretty nasty things happened right around now, right? In terms of the past. So yeah, maybe there's just sort of a general thought that it's like, okay, well, whatever the bad vibe is here, let's just not launch any rockets right now. So who knows? Yeah. But yeah, there has been a substantial slowdown, but yeah, hopefully that'll get ramping back up, right? Because it's wow, we're already into the second month, and
yeah, they've got a lot of plans for this year's launches, so they need to get them going.
Yeah.
And that one that's tomorrow is out of French Guiana. Yeah. Oh.
Okay. Cool. Yeah. I think that's where their primary launch facility is. I don't think the European Space Agency, I don't think they have any other launch facilities anywhere, do they? Yeah, I don't know.
I don't think so either. It looks like they have a number of different pads down there, but yeah,
Yeah,
I think it's all in the same place.
Yeah, and that's a good spot because that is, of course, really, really close to the equator, and at the equator, your velocity is sort of the highest, right? So that's just a little less fuel, that you actually have to use, to get up to the orbital speeds. So and that's a good thing, right? So yeah, that's a wise choice, for sure. So all right, well, cool. Yeah, I think we're expecting a Falcon Heavy launch this year. Bunch of Falcon 9s, I know that. I'm trying to think if there are any other extraordinary ones.
Well, the Dragon capsule is supposed to go flying.
Yeah, that'll be nice. That'll be nice. But that's the unmanned one, right? They're just testing all that out, right?
Right.
Yeah, but they're going to orbit it, right? Is that?
I think so. I think it's going to go around a few times.
Nice. And is Blue Origin? They're really, really close to having their well, and I mean, it's not going to orbit, but they are going to have their suborbital thing. I think that's supposed to be happening this year too, right? Wow.
I think so. Yeah.
Yeah. Wow. Yeah. It's an amazing time. It's and now that there's more than one player, right, or two players, right? There's a lot of players. We don't want to see any kind of accidents, right? But it's not going to be such a huge setback for space travel, in general, right? So I mean, definitely don't want to see a setback, but it's not just one launch thing now. So if there is a failure, there's 3 or 4 or 5 others that are going to continue. So yeah, I think that's pretty good progress. It's about time. Too. So cool. All right. Well, sweet. Speaking of launching, I'm continuing to look into this lunar telescope, and I came across and when I saw it, I was like, oh, I think I remember that back in the mid 90s, there was a plan to actually send a 1 meter size telescope to the moon that was going to telescope, right? So it was just going to land and point and not move, right? You can actually do a lot with that. I mean, you're limited, of course, but there's much that can be done, and they actually got it at least through what they call the Phase A study, where they laid out in extreme detail. I've got now this 700 plus page document that goes through all the systems and the subsystems, and how they're going to solve all these problems and stuff, and so back in the mid 90s, they were not only thinking about putting a telescope on the moon, but they concluded that the technology was available to do that. So you know, the one thing that I haven't been able to find out yet is why all these scopes, that one that was going to be sent up sometime in the early 2000s, and the Chinese telescope up there now are all looking in the ultraviolet, right? There's sort of a focus on that wavelength regime, and I haven't been able to figure out why exactly the focus was on that. I can sort of kind of understand the infrared, right? Kind of, but I'm not exactly sure why they wouldn't want to do like a visible thing. Now, this telescope that I'm talking about was called the or here I'll just show you the I'll show you the document here. I will share my screen. And hide that. So this was called the Lunar Ultraviolet Telescope Experiment. So as you can see, this is what they're calling a Phase A final report. And I think this is just, I mean, reading through this, it's sort of a feasibility thing. It's like, okay, what do we have to do? And so, they got into a lot of the details here. And as you can see, it's a 774-page report that basically says the conclusions is that yes, we can do it. It's going to be hard, but we can do it, right? And what they were talking about, was a 1-meter telescope, right? That's pretty big, right? I mean, what I'm talking about is like a, 1/5 of that diameter, right? Like a 0.2, maybe a 0.25 or something like that, right? So much smaller, but this is what they were talking about. And the reason why my memory was jogged on this was because of the name of the principal investigator here, John McGraw. John McGraw worked at Stewart Observatory while I was a student there, and he ran a transit telescope up on Kitt Peak that that I was lucky enough to work on for at least a few times or so. And yeah, what this telescope was, it just pointed to one declination towards the sky, right? And as the Earth rotated, of course, the sky moved, and so they would take picture after picture after picture after picture, and worked really, really well for years and years and years and years and years. They had lots of data, and I'm trying to remember. There was one galaxy. I'm pretty sure. Now I'm really scraping into memory land here, but I think it was set to look at a declination of plus 26 degrees. And at plus 26 degrees, there was a really, really nice looking galaxy that went through. It was in Virgo, and oh man, I'm trying to remember what the number was. I'm going to really stretch the memory here, and I think it was 4779. Oh no, I don't think so. No. Well, it was called the CTI Observatory. So let's see if I can. Observatory. Let's see if I can. CTI. Oh wow, it's not even listed. It's this, and I don't even remember what the CTI stands for. Something transit instrument. Transit instrument. Not going to belabor this too long, but
Is it it's called the Kitt Peak National Observatory?
yeah, that's Kitt Peak. That's about it's about a 2.5 hour drive from my location to my west. Yeah. But yeah, they don't even talk about it anymore. Wow. Okay. Yeah. Well, don't remember exactly, but anyway, he was in charge of that. Moved to New Mexico, and got involved in this project, obviously. And again, his idea was to put a transit telescope up on the moon. Like I said, big, but kind of cool. But yeah, they,
Kind
my
of
whole
big,
point.
pretty much caca when they scanned that paper for sure.
Yeah, they, this is obviously, some kind of a scan that has then been sort of interpreted. But yeah. But point is
I
that
think I would come with a better job for sure when it comes to scanning stuff.
well, I'll bet you that you probably could, but it is what it is. Point is, though, is that they were thinking about and came up with solutions to all the problems in terms of temperature and power and just all of it, right? There's lots and lots of details in this. So yeah. So this system was actually in a competition with an orbiting ultraviolet telescope called GALEX, GALIX. And guess who won the competition? You're right. It was GALEX. So actually, GALEX, is it EX? Okay, it's EX. Sorry. GALEX was launched in 2003, and it was an orbiting telescope, right? Let's see. I didn't really look too hard at this. 290 watts of power here. I'll zoom in a little bit here. Wow. So it was launched on a Pegasus, right? So that's a rocket that they put on the bottom of an airplane, and they fly the airplane up pretty high. I forget exactly how high, and then they launch the thing off of that. So that's pretty cool. I want to see what size. Okay, so it's a half-meter telescope, right? Half meter. So that flew for quite a long time, right? Planned for 29 months, lasted what, 122 months. So not too bad, right? Not too bad. And they apparently got some good data out of it. Here's some pictures. But again, this is in the ultraviolet, right? Oh, here's a picture of the actual Pegasus rocket there, right? So they fly this thing up really, really high. I forget exactly how high, and then they drop this thing. They have to drop it, right? They just drop it, and hopefully the rocket fires, and then it goes out into space, right? So, but yeah, that's hair raising. So anyway, as I said, GALEX was in competition with I don't know how they pronounce this, if they pronounced it Lute or Lutie. I'm not exactly sure. I think that's kind of a lame name anyway. But in the end, it wasn't picked. But the interesting thing, for me at least, is that a lot of the
What
problems.
actually will make Lutie better than GALEX and vice versa?
Well, that's part of what I want to investigate, right? I want to find out, why did they choose GALEX over Lutie, right? And I don't have an answer to that one yet. Yeah. So, I mean, for some reason, maybe it was cost. Maybe it was, slightly different technology. Yeah, hard to know. Yeah, but I'm going to try to find out exactly why. But I just like the idea, that there's a lot that has already been thought about, and using technology from the early 1990s. They were pretty comfortable with the idea that they could do it, right? Here, I'll show you let's see if I can find a picture of the idea. Here's the optical configuration that they had. So here's the primary mirror, right back here. So light comes in this way from the left, hits the curved primary mirror. It's a concave mirror, right? That gets reflected to a secondary mirror that's convex. But as you can see, the secondary mirror has a hole in it, as does the primary, because once it hits the secondary mirror, that light gets reflected back to a tertiary mirror, which looks pretty flat. It's hard to tell here. It might have a little bit of a curve. We'd have to look at the specs. And then the actual camera was here. So that is very, very much a folded light path, right? They wanted to conserve space, right? Because they got to put this thing in a rocket, right? So they need to make this sort of as small as they can, and so they came up with this pretty interesting design. Now, is there light loss? Well, yeah, because that much of the primary is gone, that much of the secondary is gone, but most of the area is out here anyway, right? So it's not as much. It's not as much as what you might think. They probably give a number in terms of the amount of light lost, but yeah, so that's kind of a cool optical design. And then let's see if we can. There's the light shade for it. Let's see if we can find an actual picture here. I thought, yeah, they were going to use the RTGs, so it was going to be a nuclear device of sorts. So yeah, that's what they came up with, right? The telescope up here. Here's all the landing legs. Here's the RTG, the power source here, so yeah, they had this all worked out. So very, very cool. That's just less things that any kind of project that I'd like to be involved with. It's just less things that I gotta actually think about and come up with, right? But yeah, they were talking about a 1 meter telescope, which is big. I mean, that's really, really big. I don't think anything that large is needed. I did notice that they were estimating that, I don't remember what the exposure time was, but they could get down to like 27th magnitude or so with that. So yeah, they wanted to go, as faint as they possibly could. So very, very cool. But yeah, this is just a huge, huge document. Lots of details, lots of analysis. They were looking at, different kinds of materials, to make the mirror out of beryllium, silicon carbide, fused silica. So yeah, just lots of plots, lots of images, and going through the entire system, right? Yeah, after all this effort, right? All this effort, it just gets dumped, right? And it's like, oh wow, that must have hurt. That must have definitely hurt. But that's how it goes, right? When you've got limited funding for things, and you can only choose one out of all your choices, you've got to decide on what you think is going to get the most bang for the buck, right? And GALEX won, and Lutie lost. That's how it goes. But
so who was the guys behind GALEX? What organization?
Well, I'm sure it was a looks like it's well, let's just pop up here and see if there's anything relevant here. So it's right. So it looks like it was a NASA thing, right? A JPL thing of some sort. But then it was taken over by Caltech in 2011. Am I reading that right? So yeah, we'd probably have to get into the same kind of paperwork that Lutie had, because they also had, a phase A and all the design things and all of that. So GALEX went through the same process, but of course, being in orbit, right? They had a different set of problems to solve, right? So I mean, it looks like they were solar powered, right? For one, it was a smaller telescope, right? It was 1/2 the diameter of Lutie, so roughly 1/4 the the area, collecting area. So yeah, that was just chosen over Lutie, which you got to pick one. You pick the best one. So and that was obviously, hopefully at least the best choice. And I think so. I mean, it was planned to run for 29 months, and it lasted for 10 years. That's pretty good. It's not too bad, right? I don't know if you would get that kind of behavior on the moon. I don't know. I mean, the moon is a very dusty place. There's a lot of static electricity, right? So things can get pretty dusty pretty fast. The temperature extremes are similar, except you have this huge heat sink, right? The moon itself, and so, well, that's either a source of heat or a source of cold. So you have to deal with that. There's a trade-off, right? And I guess for this, it was decided that GALEX would go and Lutie wouldn't. And I gotta say, based on the amount of time, that was a good choice. Now, I guess my hope is that all the GALEX data is available. I would think so. Newsroom, education, researcher, resources, GALEX data releases. Yeah. Okay. So they've had actually a bunch of data releases. Data release 6 was supposed to be delivered in April and June of 2010. So I don't see any other. Of course, all this is over on MAST now, so that's pretty cool. We can actually go over and, oh yeah, here it is. Yeah, so here's the, I guess they're calling this the GALEX release 6/7 for some reason. So I guess these are, yeah, oh, okay, yeah. So these are all the previous releases, and not quite sure what these numbers are, but yeah, so it's all there. Cool. Nice. Nice. We will have to dive into this at some point. I'm not quite sure. I guess these are the different instruments, right? AIS, DIS, MIS. Without diving into it a little bit, it's hard to tell. But let's just do a quick dive here. What should we go for? Let's go for, let's see. How about Messier 57? Let's see. It'd be absolutely crazy. Oh, yeah, they did. So Messier 57 is the ring nebula up in the constellation of Lyra. And, oh, okay. Don't quite know what we're seeing there. This is in the ultraviolet, so so there's a lot of like internal reflections and whatnot. So I'm not seeing the nebula here, but let's actually click on this and see if we can get an idea of the field of view here and all of that. 285 and plus 30, that's really, really close. Wow, so this is a big field of view. I don't think that's it. That looks a little too round. Oh, where exactly? Let's see, 57. Let's see exactly what the coordinates are here. So 1853, 35. 1853, 35 times 15 is 283.39. Oh, okay. Here they actually have the RA and deck. Okay, so that's off by a couple of degrees. Okay. And then it's plus 33. Okay, so this, yeah, this is looking off. Wow, that's a really big field of view. If this, oh, okay, yeah, no. So 1907, 1906. Okay, so these are 1 arc minutes. So this field of view is what? Roughly 1, 2, 3, 4, 5, 6-ish or so arc minutes in size. So this is a very, very, very narrow field of view, extremely narrow. It's about 1/4 of the field of view of my telescope. So it's tiny, very, very tiny. So, well, let's see if, do they actually have, yeah, here's the RA index center. So let's see if we can actually see it. So we're at 283.395, 283.9, 283.84, 278. Yeah, doesn't look like it's really. Yeah, but then it's a deck of 27, and this is a deck of 33. So, yeah, it looks like it was sort of pointing in that area, but it doesn't, at least from these coordinates, it doesn't look like they actually ever got it. 278. What was it again? 33? Yeah, I'm not seeing a declination here of 33 anywhere. So kind of close in deck, but then far away in right ascension. So, yeah. All right. Anyway, kind of neat to see these ultraviolet views of the sky. Kind of neat. Not exactly sure why, depending on the optics and all that, but all the stars have, this fuzz around them. So that is probably something to do with the optics, I guess. A little bit of distortion. See how they're extended a little bit like that. Yeah, you just got to deal with that. Good resolution, though. Wow. Pretty cool. Pretty cool. So, I don't know. Let's trying to think of something else that would be smallish, and something that they would target. maybe like M82, although that's really, really big. But let's see if at least there's a, I'm not seeing anything. Again, it sort of looks like they're pointing all around it, but there's a lot of internal reflections. I don't quite know what that is. It's probably an internal reflection, because I think Messier 82 is pretty big, but wow, that looks like something. If they're looking in the ultraviolet, then they're going to be seeing very, very energetic portions of these galaxies and not much of anything else. But M82 is really, really big, and this object, if it is an object, it sort of looks like it is. There's some structure in there. That's really, really small. So, and M82 is pretty distinctive. I don't know if you all remember that one or not, but we can pull up a picture of it here. Let's see, what's the best one? I don't know. Any of these will do. Here's, yeah, I mean, through a telescope, it sort of looks like that, right? I don't know why it's blinking like that. Let's, yeah. In fact, there was a supernova in it a couple years ago or so. But yeah, I mean, it's a very elongated galaxy with all this nasty stuff in here, and I'm not seeing that there. So that must be some other galaxy. That's my wild guess, crazy guess. But let's see if any of these have, because I mean, it's going to look really, really big in this very, very small field of view. There's something else interesting there. Again, it's hard to tell. That's more of a distorted object of some sort, but yeah, I can't be sure if that's M82 or not. Which one was that? That one, number 10. So 143.96 and 71. Yeah, see, the declination here is 69. So that would be, I think, way out of the field of view. Oh, no. Yeah. What's the right ascension here? 955, 52 times 15 degrees per hour. 148.96. 148.96. Yeah. Again, it sort of looks like they're just sort of going around it, not really getting too close to it at all, because although there's another object there. This looks like some kind of an internal reflection, but there's definitely an object down here. Again, I just want to confirm. Yeah, see, this says 10 hours, 36 minutes. Here's 34, 32, 30, right? So this field of view, well, in degrees, is going from 6815 to 6930. So actually, that's almost 1 degree in size. Okay. It's almost a degree in size. Anyway, it's nice to know that all this data is available still. Looks really, really good. And what this tells me, right, is if you put a similar instrument on the moon, you're going to see exactly the same thing, right? In space, right? There's no real difference between what you're going to see in orbit and what you're going to see on the moon. The moon has sort of a negligible atmosphere, if you want to call it that. So there isn't any kind of distortion. There's no Rayleigh scattering. So there's no blue sky or colored sky of any sort. It's always dark, except if you look at the sun or the Earth. So cool, though. Very, very cool. So yeah, it looks like GALEX won out on that, which is fine. No problem. No problem at all. But yeah, it's kind of neat that all this is available. I kind of like the interface here, where you can just sort of move over the JPEG things, and it pops up a quick look kind of a thing. Kind of neat. Yeah, I think I want to investigate this a little bit more, because I don't know anything about GALEX at all. It's kind of interesting too. I mean, in this image, right, most of the stars look yellow, but then there's this big bright blue one down here. So again, we're looking in the ultraviolet, so they've colorized these, but obviously, well, maybe not extremely obvious, but I mean, it looks as though they've observed these fields of view at different wavelengths, and then they've colorized those. But wow, lots of galaxies. There was a nice one over here. Look at that one. A nice barred spiral galaxy. Look at that. That's pretty nice. There's another little smudge here, a little smudge there. So yeah, kind of hard to tell exactly what's going on. These almost look not in focus too, right? And of course, this is some kind of a reflection of some sort in this and these here. So yeah, pretty cool though. Pretty cool. Anyway, I was just kind of excited to see that report about a plan to put a pretty sizable telescope on the moon. They made a good science argument. They worked through all the details. They're a little bit ambiguous on the lander. That was one of the things that was sort of talked about a little bit, is that they really didn't have a solution for a lander. So maybe that was one of the reasons why it wasn't chosen. But I just like the idea. They went through all of that and did a lot of work, right? I mean, lots and lots of work. Lots of people. They actually went through many different kinds of simulations, made a bunch of different models. From sort of the simplistic spreadsheet types of stuff to actual full out modeling of what the temperatures are going to do to things, and where it's going to be able to point, what it's going to be able to see, all of that. It's really, really cool stuff. So kind of interesting that, what is that? Wow, that's like 25 years ago now. They were thinking about that. So yeah, lots and lots of work done. So yeah, I'm gonna definitely be devouring that report over the next couple of weeks here. Just to see, what the details were, how far they got, and they thought that it was a viable thing. So I'm gonna trust their judgment. Maybe we know more now. And it's sort of like, well, we shouldn't do it because of blah, right? So far, I haven't found any of those kinds of showstoppers, right? Lots of obstacles, but no showstoppers. So yeah, well, cool. All right, well, I am noticing what time it is, and it's just a little bit after the hour. I like to keep these to about an hour if I can. Usually it goes over that. I haven't even been looking at the chat or anything. So, all right, not a lot of excitement over there. Ingrid, if you're still there, howdy. Nice to see you there, all the way from Brazil. So she's been popping in from time to time. She turned me on to a Brazilian fellow who is doing well, is very, very actively doing lots of astronomical stuff, and I wish I knew Portuguese, because one, I can't understand a word he's saying, and two, he is, I think he is talking really, really, really fast. I mean, really fast. I thought that we Americans here, talked really, really fast. Man, no, this guy is just blazing along. So I'm hoping. I actually need to check his past videos if they have English subtitles, right? Because I mean, whatever he's saying it a lot, and I definitely like to hook up with him, because yeah, he sounds like he knows what he's saying, and good stuff. He does live streams, I guess, from time to time, and then he's I've only been following him a couple of days, and in fact, what I should do, instead of just talking about him, let me find a link to his YouTube channel, and I will post it here. Let me see if I can find it really quick. Should be able to. Let's see. So we're pretty close to new moon, right? We're this might actually be new moon day, sure, but we're pretty close to new moon, so that'll be the nice waxing crescent will be popping up over in our west again after sunset, as it does. Let me see if I can find him here really quick. Got to go back in my history. That's probably the easiest way. There it is. And I'm not even sure how to pronounce his site. Well, mute that. Go over here and grab this actual link, and I'll put it over in the chat. But yeah, I wish that I knew Portuguese, as I said, but man, I barely know English. So and not much is obvious here. So, but anyway, check him out. He's got a pretty big following, and when he does his live streams, he's got at least like 150 viewers or so. So that's a pretty sizable live stream. And of course, they're all chatting in Portuguese too. So I mean, I can't even follow the chat. Ingrid is nice enough, to say, hi. But that's about it. But that's okay, right? Most of the population of this planet does not speak English, so I don't expect that at all. In fact, I think it's a little unfair that lots of countries, their kids are sort of forced to learn a second language. I don't know if that's exactly fair or not.
You can blame the people that built the Tower of Babel.
I guess, but I mean, it is nice to have a common language, right? So you got to choose one or two, say, right? So I mean, to a certain extent, it makes sense, right? We've sort of chosen one, that's the one.
Well, if there's a possibility that if I was still in school, I would learn another language, for sure, I could either choose French or Spanish.
Yeah, I tried pretty hard, but I see my problem is that I don't learn things in sort of the classroom way, right? By memorizing things and all that. The only way that I would be able to learn a language is to actually move to a place where they speak that and live there. It'd probably take me a couple years, right? Because then you're sort of forced to learn it, and you're surrounded by it, right? It's not exactly a memorization thing. It's just a learning, just like being a 1-year-old and learning your first language. It's that kind of thing. You just absorb it, right? And you hear it all the time. That is the only way that I think that I'd ever be able to learn a language. And since
I think my cousin did that one time when he married a Brazilian and stuff, and she had to go to Brazil for quite some time.
Yeah. We'll see.
And it pretty much ended up in a big D and don't mean Dallas for sure, because he kept on meeting other women.
Oh, well, I guess that can happen. You want to try to avoid that, but yeah. So yeah, my prospects for learning a second language or a third are extremely slim because I'm not moving. So yeah, and I mean, I would have to move somewhere for, like I said, at least a couple years, right? So
I'm still learning my first one.
Yeah, me too. I don't know if this is a universal thing or not yet, but I've heard that computer languages are now considered foreign languages. So I don't know if that's a thing now for sure or not, but back when I was in school, that really would have come in handy. So, all right, everybody, I'm going to get out of here for now. So thanks for coming in again. It's been great. yeah, just sharing the passion, talking all things astronomy. You know, we never know exactly where the path is going to go. So I don't really try to plan these live streams or anything. The only thing that I try to do is sort of limit, right? Because we have this whole universe to talk about, and so it's like, okay, what are a few possibilities, right? But then within that, who knows? It can go anywhere. All right. Well, for sure, I'm going to get out of here for now. So take care, everybody. Have a great evening, a great day. Smash the thumbs up if you so desire. You can subscribe if you like. Hit that bell, and spread the word. Spread the word. So, all right. Well, I will be back here again in a little less than 23 hours from now, 2 hours UTC, practically every single day. I'm going to have the live stream for the 10th is definitely canceled. There's also a possibility that the live stream for the 14th is also going to be. So that's not a firm yet, but definitely for sure the live stream for the 10th is not going to happen. I've got a musical gig, and I'm just not going to be here. So, but for the most part, I'm here every single day. So let's do this again tomorrow. Yeah. Just a little less than 1 Earth spin away. All right, everybody. Take care. I will see you later. Bye.
There.
Bye.